Hi everyone to another episode on Awesome Maths. Today we will solve a couple of problems which are to do with geometry and areas and volumes. So are you all ready? So the first question is the volumes of two spheres are in the ratio 64:27. If the sum of their radii is 14 centimeters, find the two radii. Right? So very simply our first step here will be let the radii be R1 and R2, right? So proceeding along, what are the things that we know? First of all, what is the volume of a sphere? So volume of the first sphere is equal to 4 by 3 pi R1 cube, right? And volume of the second sphere is 4 by 3 pi R2 cube. We'll put here then to ensure mathematical continuity. Okay. Now what do we know? We know that V1 by V2 is equal to 64 by 27. This implies, what does this imply? 4 by 3 pi R1 cube divided by 4 by 3 pi R2 cube is equal to 64 by 27, right? Now 4 by 3 pi and 4 by 3 pi here will get cut. So what do we have in the end? We have R1 cube by R2 cube is equal to 64 by 27. Moving along further, we have to do the maths with cubes. So R1 by R2 whole cube is equal to, now this can be written as 4 by 3 cube, right? Correct? So then that gives us R1 by R2 is equal to 4 by 3, right? So this is our first bit of the answer to the problem. So, but we also know that R1 plus R2 is equal to 14, right? So, R1 plus R2 is equal to 14, but we just found out that R1 by R2 is equal to 4 by 3. So, if we call this equation 1, our second equation is R1 is equal to 4 by 3 into R2. This we will call 2. So substituting for this for R1 in this equation, we get 4 by 3 R2 plus R2 is equal to 14. This implies, so 4 by 3 R2 plus R2, what will that be? That will be 7 R2 by 3 is equal to 14. That gives us R2 is equal to 3 into 14 by 7. These will cut, is equal to 6 centimeters. So, sorry, there is a lack of space here. So, R2 is equal to 6 centimeters and R1, as we know, R1 plus R2 is equal to 14. So, R1 is equal to 14 minus 6 is equal to 8 centimeters. So we have R1 and R2 solved here. With that, we will move to the next problem. Okay, so moving on to our next problem, which will be a lot more difficult than the one that we had before. So we have an ice cream container. Everybody loves ice creams and we have got summer coming in India. An ice cream container is in the form of a rectangular cuboid, measures 4 centimeters into 5 centimeters into 8 pi centimeters. So we have a rectangular cuboid of ice cream that measures 4 centimeters into 5 into 8 pi centimeters. This is used to completely fill 10 ice cream cones with hemispherical tops for children. Want ice cream, children? If height of the conical portion of each cone is 4 times its radius. Find the radius of each ice cream cone. Looks quite complex. Well, it is a bit tricky, but nothing for us when we use the concepts of awesome maths. So the first thing that we do in problems like this, right, is to draw. So we have an ice cream cone. Radius of each ice cream cone is r, right? And we have a height of h, right? So this is the hemispherical top of ice cream and the entire cone is filled with ice cream, right? So h is equal to 4r. This is what the problem tells us, that h is equal to 4r. We'll just write it here, right? So you can just convert this to h is equal to 4r here. So in our problem, when we solve this, instead of writing h as the height, we will just write 4r as the height, okay? Now the simplest part is we know the total volume of ice cream, right? So the total volume of ice cream is this, 4 centimeters into 5 centimeters into 8 pi centimeters. So what we write is total volume of ice cream is equal to 4 into 5 into 8 pi is equal to 160 pi centimeter cube, right? So this is the total volume that we have. Now this is used to fill 10 ice cream cones, right? So what is the volume of each ice cream cone? Cone equals 160 pi divided by 10. Okay, so this is equal to 16 pi. So 16 pi centimeter cube is the volume of each ice cream cone. But from this diagram, what do we know the volume of the ice cream cone to be? So V again, which is the volume of the ice cream cone, this is the volume of this conical section plus the volume of this hemispherical section. So what is the volume of this conical section? So 1/3 pi r square h is the volume of any cone, right? So 1/3 pi r squared, but h is equal to 4r. So we write h as 4r plus the hemispherical top. So the volume of a hemisphere is 1/2 into 4/3 pi r cube, right? Which is the volume of a sphere. So we have divided that by 2. So what does this give us? This gives us, so 4 pi r cube by 3 plus, here we have, we will cut this, so it comes 2, this is nothing, so that is 2 pi r cube by 3. Moving on, this gives us 6 pi r cube by 3. We cut this, this becomes 2 pi r cube, right? But we already know that the volume of each ice cream cone is 16 pi. So we write here, hence 2 pi r cube is equal to 16 pi. Okay, this implies you cut the pi's, you cut this, r cube is equal to 8. So r is nothing but cube root of 8, which is equal to 2. So the radius of each cone is equal to 2 centimeters, right? So isn't this a simple solution following our concepts to, again, a seemingly complicated problem, right? So if you want similar problems, kids, and if these problems interest you, please do subscribe to my videos and like and share them as well, so that this content can reach out to more people and help them in their maths journey. Thank you. I will see you in the next video. Hi kids, maths is the language of the universe and I am doing everything that I can to make maths problems a bit easier for you. So if you like my videos, I would just request you to please like, subscribe, share all of my videos, and also send me your comments on what new maths problems you would like me to solve for you. Thank you and all the best.